Okay, so for this one, what we want to do is the following. So the first part's really easy. And this is the sort of thing that is a nice long kind of problem that you could see in a test or an exam. Not exactly the same, but similar. So that one's really easy. You're just finding velocity and acceleration. Take the derivative. So v is equal to s prime t. So that's really easy. That's just going to be 3t squared minus 3. Perfect. That implies, though, that you can actually factor this, because you're going to see draw a sign diagram. So this is pull out the 3. So this is going to be t squared minus 1. Well, that also can be factored. So 3t minus 1, t plus 1. Right? So again, what we see, we can reject the negative 1, but we keep the 1, so this is our 0. So notice that when you do this, just put in test points, put in a half, and you'll see this will be negative in your velocity. Where is it positive or negative? Just put in right in here, like say t is a half, t equal 0.5, t equal 2, right? So you'll see it's positive, etc. So this will be positive. Now acceleration, well, that's just the derivative of the above one, or velocity. So then that's just going to give me 6t. Now that implies a sign diagram where at 0 it's always going to be positive, because no matter what t I put in, and t is always greater than or equal to 0, so no matter what, it's positive. So that's really nice and easy. And the sign diagram. So B, what you want for B is the initial conditions, and hence describe the motion of the particle. So just test using the given formula. So S of 0 is equal to, so that's the initial, is t equals 0. T equals 0 is your initial. So this is going to be 0 cubed minus 3 times 0 plus 1. This is going to be 0, 0, 0 minus 0 plus 1. This is 1. So there we go. It's going to be 1 centimeter. Right? And if you take this at v of 0, because we want to take it, you'll get minus 3 centimeters per second. And then acceleration at 0 is going to be 0. So what do you see? Well, therefore, let's just describe. Particle is 1 centimeter to the right of origin, right? 1 centimeter to the right of origin. We'll draw the picture below. Moving, because it's negative, it's moving back to the left. So you know it's on the origin. It's 1 centimeter to the left. So 1 centimeter, or 1 centimeter to the right, sorry. And it's moving that direction back towards the origin. To the left at 3 centimeters per second. Right? So there we go. C, what we want here is to describe the motion at 2 seconds. Well, then we're doing the same thing. Put in at 2 seconds. So when you put it in at 2 seconds, you're going to have 3 centimeters at velocity of 2. This is going to be 9 centimeters per second. And acceleration at 2, well, that's going to be 12 centimeters per second squared. So, but there you go. So you can already kind of see what it's doing. So this is going to be 3 centimeters to the right, and already of the origin, and moving to the right at 9 meters per second, and it's accelerating, right? So we'll see in the diagram. So D, we'll put in the D, because I think E is where we're going to draw our motion diagram. So now D is saying find the position of the particle when it changes direction. Well, there's only one place it changes direction, and there it is. You can change the direction by looking at the velocity, right? The sign diagram of the velocity, because if it changes from positive to negative or negative to positive, that's a sign change. So we know it's happening at 1. So S of 1, S1, well, that's going to equal 1 minus 3 plus 1, which is then add those up. It's minus 1. So this means the particle is 1 centimeter left of origin, right? So we then see the E, our motion diagram. So this is motion diagram, right? That then is here, and we've already gotten all the information. We have 0, we have 1, 2, and 3. So this is 3, 2, 1. And we also know what's going on. Minus 1 because we were just looking at the change of direction, right? It happens, where does it happen? We just were talking about that. I believe it's change of direction at minus 1, right? Because it's asking, so where does it find D? See, there it is. Find the position the particle is changing direction, right? So when you plug in 1, you know from the velocity diagram right here, that's a change of direction at 1 second. It means then you're changing particle at minus 1, which is left of the origin. So this is our origin, our 0. That's our O, right? Origin. So that means for 0, where am I? At 1. So this is t equals 0. I'm right here. So what I'm doing is I start here, and I'm going to zoom this way. And at minus 1, we turn around. Now we're coming back. So this is going to be t equal 1. And then at 2 seconds, you're at 3. Right? So this is t equal 2 because you see that right here actually, right? So you're seeing this right here, right? Or even right here at 2 seconds, it's at 3 centimeters. So the motion diagram is pretty satisfactory, right? So there we can see the turning point. So what we can say then in F, right, for what time interval is the particle increasing? Now remember, if it's the speed are increasing, right, A needs to be greater than 0 and velocity needs to be greater than 0 because that's increasing, right? So they're need to both be positive. So look at here. We know acceleration is positive everywhere, but only velocity is positive, equal or greater than 1. Right? So that's time-wise. So that means t greater than or equal to 1. If t is right greater than, then particle is increasing. It is, or well, I can actually speeding up. I'll just say that is speeding up. Is speeding up. There we go. Done. And that's it.